Well, welcome to another DevNation Tech Talk. We're going live right now with you guys to talk about secrets. So if you've not heard about secrets, well, hopefully you have heard about secrets, but you shouldn't actually know the secrets. That's the secret of secrets, is you don't actually know what the secrets are. I'm just trying to be funny at this point. But we have an amazing guest star today with Alex Soto. He's going to be talking to us about Kubernetes secrets, and you should know what those things are because guess what? They're also known as passwords. If you have passwords, you might care about these sort of things. But the point of it is you want to basically keep your secret secret and still use them in the context of a Kubernetes-based application. So I think this is going to be a really fun tech talk. Please do throw your questions into the Blue Jeans chat. We'll be there in the Blue Jeans chat, into the YouTube chat, and then we'll see your questions there. I'll be posting some points here very soon, meaning I'll have some slides for you guys. I'll have some other links for you, so be looking out there, but also throw your questions there. At this point, let me turn it over to Alex. Alex, over to you.
Hi, Bar. Thank you very much. Let me share my screen. Oops. Wait a second. Share my screen. Why I cannot share my screen now? Yeah.
You gotta find it.
Now, here. Now you can see my screen. Okay.
There we go. Fantastic.
There we go. Yeah. Okay. So, my name is Alex Soto. I work in Red Hat and I'm author of the Java Microservices and the Quarkus Cookbook. And please, if you have any question, you can do it in the chat in the YouTube. But if there's a question comes later, just ping me on Twitter, or also you can send me an email to soto@redhat.com. So what is a secret? I take the definition from the Cambridge Dictionary. It says that a secret is a piece of information that is only known by one person or a few people and should not be told to the others. And that's really important, right? And in this talk, I'm not going to talk about, I'm not going to speak about secrets of user secrets. So I'm not going to talk about how I can store the user information securely. I'm going to talk about passwords, about certificates, about DB usernames, DB passwords, API keys, all this kind of stuff. But first of all, I'm going to give you some kind of funny facts that are interesting, and then we're going to get started with Kubernetes, so please keep until the end. Secrets have been around us for a long time. I just searched for the backmask message songs. I found that, if you go to this wiki page entry, you'll see that there is a lot of songs that contains a backmask message. So if you listen a part of the song in reverse, then you see something. For example, The Rain of the Beatles, Loser from Beck, Perfect Sense of Roger Waters, or Empty Spaces from Pink Floyd, all of them contains a backmask message. And it's really easy to maybe notice these secrets because you're listening to music and suddenly you start hearing something strange. And it's like, okay, let's listen in the reverse mode and see what's happening, right? So it's a secret, but it's not really a cool stored secret. But in music, there are other ways to store a secret. And let me introduce you the B minor key. The B minor key is a key in the music that is used when the author wants to express death, wants to express that, your fate, right? That you accept your fate. And we have seen in several musics. Let me put here just 3 examples. Rite of the Valkyries, really famous, right? From Richard Wagner. We've heard this in Apocalypse Now, right? In the Rite of the Valkyries, in this opera, in this part, the Valkyries are in the warfield, right? Preparing to take all the dead heroes from the warfield to the Valhalla. So it's about death. There is another one, Symphony No. 8 from Franz Schubert. It's also in V minor key. And, basically, it's in V minor key because it was composed when he knew that he was going to die because of syphilis, right? So he was accepting his fate. And the funny thing is that, for example, if you enter the Smurfs, every time that Gargamel is planning something to capture or kill a Smurf, it sounds this song. And a third example from Grieg, Edward Grieg, Per Jean. Per Jean in the Hall of the Mountain King, right? In the Mountain King, it's a troll mountain, and Per Jean is there, and he's trying to escape from the mountain, and all the trolls are looking for him, right? So you can see the song, and you notice that someone are trying to kill him or trying to take him. So again, it's a B minor key because it's when the Virgin life is in danger. And you'll say, and what is the secret here? I'm going to show you what is the secret. Probably most of you know The Show Must Go On from Queen, which was released on 14 October 1991, and Freddie Mercury died on 24th November 1991. And the funny thing is that when The Show Must Go On was released, nobody knows that Freddie was really ill. Nobody knows that, and that he was going to die soon. This was unknown by the most of the people. But you know what? The Show Must Go On was written in V minor key. Another secret. So this is a very well stored secret, right? The song was telling us that something really wrong was going to happen. Okay, so storing secrets, there is no silver bullet. It's just it's more like an onion. It's creating layers. So in case that one layer fails, you've got another layer securing and another layer securing. But again, there is no 100% system secured. It's just about adding layers of security. So we've talked about Kubernetes and secrets. So let me just introduce you really quickly. Kubernetes cluster. There are master nodes and the nodes, the kubelets where all the worker nodes, which are where all the working things are happening. And the important thing here for the secrets is the master node and the etcd. This is where the secrets are stored. And they are in the master node, not in the worker node. So what is etcd? Well, etcd, as I said, they are running in the master node. Well, this is by default. You can change it. You usually really secure Kubernetes installations runs the etcd outside of the Kubernetes cluster. But let's say that by default, they are in the master node. etcd is a distributed key value database and stores the state of the cluster. So all the time that we are doing kubectl get pods, kubectl get secrets, get config maps, all this kind of stuff, it's just a query to the etcd database. And as I said, the Kubernetes secrets are stored there. And please remember this because it's really important. What is a secret? What is a Kubernetes secret? A Kubernetes secret is an object that contains a small amount of sensitive data. And when you want to get this secret from your application, you can inject it as a volume or as an environment variable. So let's see an example, just another slide. I have got here my cluster. This is a Minikube cluster. You can see because if you do kubectl nodes, you see that I've got just one node, which is the master node. Okay, now let's create a secret. To create a secret, you can do it in several ways, like for example, creating a YAML file, but I'm just going to create it using the CLI. I'm going to create a generic secret called dbsecret, and I'm going to create two secrets. One is the username equal the user, and another one is the password, which I'm going to call it the password. Really secure, right? Okay, now I've created a Kubernetes secret, and you have said, okay, this is secret, right? I can do kubectl get secrets, and you see that the secret is created here. I can do kubectl describe secret. I can put it this describe, and you see here that it's saying that there is a secret in the namespace. I type opaque, and you see the keys, but in theory you don't see the value. So you see the username, but you don't see the value of the username, and the password, and you don't see the value of the password. Then seems that we are pretty good. Now let's inject this secret into a running pod, okay, using an environment variable. So I can just how you can do that. I can do deployment greeting amp, and the only thing that I need to do is add this. I want to add as an environment variable a name, an environment variable with name username, and the value comes from a secret that it's called dbsecret, and the key is username. Okay, let's run it. kubectl apply deployment Kubernetes. Now deployment amp. Okay, let's wait until it's deployed. I know that some of you already knows all these things, but it just, you can see the problems. And now let me suppose that I'm an attacker, or just I'm curious and I'm able to do this operation, just having access to the pod, the running pod. I could access that, and if I do an export, you see here that I've got declare username dev user. So if the dev user was the password, instead of username was password, then I could see the password in plain, so I could be able to log into my database. For example, if this was the database password. Okay, you said, okay, yeah, it's really easy, right? Because it's an environment variable, but you can use a volume, which is much secret because you don't know a prior, up front, where I'm going to store this password. So if you are an attacker, you don't know where to start searching on. Let me show you this. Then let's do a quick curl delete -f. Let me undeploy the previous version. And now let me deploy another. Let me show you how it looks like. It's another one, but now the secret is added as a volume and not as an environment variable, and it's pretty much the same. I'm just saying I want to mount my secret at etc/dvsec, and the content from this volume comes from this secret, and basically I want to store here this secret name. So I just want to inject these secrets as a file in this directory. So you will say that if an attacker gets access to this pod, then he will not be able to know where everything is, where the secrets are stored. Let's do an apply and see if this is true or not. I can do Kubernetes vol. And let's do exactly the same. Let's go inside the pod, /bin/bash. Okay. Now, of course, I can do, for example, ls etc/dvsec. And you see here that there are two files. One is called username, which contains the username content. Another one is the password, which contains the password content, right? So I can just go here and do cat etc/dvsec/password. And here you can see the password. So if anyone with access to the pod file system, then he will be able to get the password. But you will say, yes, it's true, but who knows where all these files are stored? It could be etc/dvsec, or it could be another directory. And that's true, but notice that I can just do a mount. And in this case, I'm going to do a grep just to make it easier for all of us, and do dvsec. And notice that here it's saying that there is a secret mounted in a temp file system in etc/dvsec. So it's just a matter of just doing a mount and then find where all the secrets are mounted. So it's really easy. But there is even another thing that I want you to be aware. Let me delete this. Delete -f, deploying Kubernetes, deployment. Okay, and now remember that I'm still having the secret here. See that I've showed you before, it's still here. And now I'm going to see how these secrets stored in etcd. So I can do a quick curl, get pod -f cube system. This is the etcd. Okay, now I'm going to just port forward. So I'm going to port forward the etcd. So now I can just reach etcd from my host, and I'm going to get access. To get access to etcd, I just need to copy the certificates, just to avoid having to have invalid certificate and so on, but you can bypass this step really easy. And now I'm going to configure etcd to get access to the etcd that it's running inside the Kubernetes. So I export this, and finally I can just do etcd control get and the secrets are in /registry/secrets/default, because this is the namespace /dbsecret. Okay, so this is how the secrets are stored inside etcd. And notice the funny thing is that it's not encrypted. The funny thing here is that the login and the password are on plain. They are not encrypted. So anyone with access to etcd or access to the backup of etcd or access to the node or the machine where etcd is running is able to get all the logins and passwords from the secrets. So notice that they are called Kubernetes secrets, right? But they are not secret at all, right? Because at the end they are stored unencrypted. Of course, let's see how to fix this first problem so we can avoid this kind of attack. And let me, for example, now delete the secret. Now I've deleted the secret, so I can do keycode get secrets. I don't know what's happening today with me with now. Now there is no secrets. Okay, let's go to the slides. So, whoops, here. So how this can be fixed? It's by using encryption secrets at rest. And basically what we are doing with Kubernetes in this case is just this one. I have a secret, and when I have the secret, I send it, I create it, I do keycode create secret, then there is an encryption configuration object which encrypts the secret and stores in etcd. And the same happens when I want to get the secret. The secret is get it from etcd, it's unencrypted, and then send it or inject it into the pod. So let's see how to do this. I can go here again, and to do that, it's a bit tricky because you need to go to the master node and just configure the master node that you want to encrypt the content of etcd. So since I'm in Minikube, at the end this is about every cloud provider do it in a different way. For example, if you're using OpenShift, there is just a really easy option in one place where you say, okay, I want to encrypt it, I want to use this algorithm, and done. And you don't need to do this manual step. If you're using GKA or EKA or AKS or all these Kubernetes implementations, you need to figure out in the documentation if there is a faster way of doing it. But in this case, I'm going to show you the Kubernetes way, right? Then the cloud providers or the Kubernetes providers provide some kind of vendor-specific way for doing the same thing. So I'm going to do a Minikube SSH. So I'm just SSHing inside the master node. Then I need to do sudo size. So I need sudo permissions, and I'm going to create one file that I've created here before. Okay, it's here. And notice that I'm just creating encryption configuration. It's a new kind. I want to encrypt the secrets, and I want to use this algorithm with one key, and this is the secret, right? This is the key that I choose to encrypt all information, and then I just create this file. Now I've created this file inside my my master node. Notice that I've done a T of and /var/minikube/search/encryption config.yaml. I've created this YAML. Now, the next thing that I need to do is restart the Minikube. Okay, to restart it, I need to do a Minikube top minus p. It's called secrets. And then start it again, but with a small difference. And secrets. And notice this, I'm just setting that I want an extra configuration, which is I'm setting that I have an encryption provider config, which is in this directory. This directory is the directory where I created this file, right? So I'm just saying I want to start the API server because this is where the encryption process happens, in the API server. So I'm just saying I want to register to the API server an encryption provider. So now I'm just restarting. It just takes maybe 30 seconds or so it's pretty fast. Let's wait a bit. Now I'm just, I mean, as I said, if depending on the Kubernetes provider, you don't need to do this kind of thing. You just change some flags, and then it automatically boots all the API servers. In fact, you do not need to reboot all the Kubernetes cluster. You only need to reboot the API server. This is the only thing that you need to do, right? But in case of Minikube, since everything is in the same place, you need to reboot all the cluster. Okay, now it's done. Notice here that it detected that there is a new encryption provider, and now I'm going to create exactly the same thing. Create secret, generic, DB secret, blah, 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 password, dev user and the password. I create it, and let's do again the ATCV of the secret. Oh wait, sorry, I missed one thing. I need to do a port forward now. And now notice that all the content is encrypted. Notice here is the key that has been used, the algorithm that has been used, and now all the secret is encrypted. So anyone could have access to the ATCV or ATCV backup, right? Or the node, but he will not be able to see anything. But of course, what's happening if I do kubectl apply -f Kubernetes deployment, and let's use for example the volume approach, and I do kubectl reports. I do a kubectl exec, so for any reason I'm able to bash the node, maybe not because I have access to the pod, but maybe because I've granted access to the node or for any reason, and now I do cat etc/dbsec/password. Notice that the password is not encrypted. So although you're encrypting in etcd side, you are not encrypting on the pod side. And also this is one of the problems that we were faced. And there is another problem, and it's that what's happened if someone has access to the master node, has granted access to the master node, and then he's able to get the etcd access, he will see all these unreadable characters. But the key is also stored in the master node, right? Because remember that I've got SSH, the master node, I created there the key, and then this has been used by the API server. So what was happening is that an attacker could get access to the master node and get the encryption key and then unencrypt the etcd data or secrets. So as you can see, you are doing a bad practice in security, which is storing the way how you can encrypt and decrypt data and the data itself. To fix this problem, I'm not going to demo it because it will take some time. Kubernetes has some kind of KMS plugins. KMS, it stands for Key Management System. And basically what you can do is just, I've got my master node, I've got a secret, and then when I get the secret, this KMS plugin connects to another system. Okay, it connects, for example, to Vault. And this Vault or any other KMS system is outside the master node. And this is the one who is responsible of encrypting and decrypting storage. So I get the secret goes to the KMS plugin, the plugin goes to the Vault system or the KMS system, which is outside the master node. This is where the keys are stored. Then it encrypts and then it stores to etcd. So what's happening here is that an attacker could get access to the Vault system, so he can grab your keys, but he will not be able to encrypt the etcd. Or maybe the attacker get access to the master node, but since the keys are not in the master node, he cannot decrypt the etcd data. So this is a really good practice of not having the keys and the data in the same machine. And this is done by using KMS plugin. Again, every vendor has a way to implement this. Then remember that I've shown you that although you are, I can show you again, although you are encrypting all the etcd, when you are injecting values inside the pod, then the secrets are in plain text. So you can just get it and see what is the value. So if an attacker gets access to the file system of the pod, can get all your secrets. Then what I recommend in this way is changing the approach, right? If you're fine using Kubernetes secrets and encrypting into etcd, and it's secure enough for you because you say, yeah, nobody is going to be able to access a pod, or that's fine, then use Kubernetes secrets. But if not, if you want a true secured Kubernetes cluster, what I suggest you is not use Kubernetes secrets and start using vaults. And vaults is just a system that allows you to store secrets and get it and set it from your pod, right? And this communication happens with HTTPS. So for example, you could have a Kubernetes node using HashiCorp Vault. There are other vault systems, but in this case, I'm mentioning HashiCorp Vault, which uses several keys. It uses a Shamir key algorithm to store and encrypt the keys. And then from your pod, using HTTPS, you can just get it, just secrets from there. So no Kubernetes secrets, just your secrets inside Vault. Okay. And then from your pod, you're just getting access from the HashiCorp Vault system. In this way, the secrets are not stored in etcd, so your etcd does not need to encrypt anything. And your secrets are not stored on disk. They are just in memory. So your pod just goes to the vault, gets the secret, and uses it in memory, right? They just store this configuration or these secrets in memory. They are never in a temp FS. They are always in the memory of the process. Of course, an attacker could dump the memory and getting the secret, that's true. But of course, dumping the memory and finding these secrets are more harder than just doing an export or doing a mount. Vault, it's just a secret engine, as I said. It supports several ways of storing secrets, for example, key value, TOTP, PKI, etc. They also have dynamic secrets. So for example, you don't need to set the password. Basically, dynamic secrets is a way of rotating automatically the password. So you're, for example, having a MySQL instance with an initial username and password, and then Vault will periodically rotate the password. So the password is changing every hour or every 2 hours or every 3 days, right? And then a Vault automatically update all the schema of the database, for example, MySQL, for example, Postgre, to the new password. So every hour you get a new password. So you need to populate this password to all your pods. That's true. But if your password is compromised, then you can easily rotate to another one. And it has different authentication methods, for example, user-based or machine-based, and it has a really good audit method. And that's all. I don't know if we still have 2 minutes. I don't know if there is any question.
Yeah, we'll give a second or two for people to catch up on the questions on the chat. Please do throw questions into the chat. But I had one question for you right away, because one thing I think is important for clarity, and you kind of said it there towards the end, right? All these secrets represent your passwords or your certificates for things like you're connecting to your message brokers, connecting to your databases, connecting to whatever, right? So my question is, how do I manage that as an operational expert, but I have all these developers who are deploying pods that have to connect to these things? Do you have any advice on how to manage a bunch of developers who also have to make those connections in their pods?
Yeah, well, from the operational point of view, probably you will need. It will depend on how you deploy your pods or your system. Usually, it's what I've seen in several places using is Helm, and Helm. There is a plugin which is called Secret plugin, it's Helm Secret plugin, which allows you to encrypt all your secrets and store them in, for example, in Git, and your secrets are stored encrypted. And then when you're doing the Helm apply, then they automatically decrypt the secret and then store on your system. It could be a kubectl create secret, or it could be, for example, storing this secret inside Vault. Ansible, for example, it has something similar. You can just do exactly the same. I've seen this using in Helm, but I know, because I've been doing some research, that with Ansible you can do exactly the same thing. So you're just having a public private key, and then you just store when you want to. You encrypt when you're storing your YAML files with secrets, you encrypt them, and when you are applying, then you decrypt it.
Okay. A couple of questions. James wants to know, of course he wants to know, when is that Quarkus cookbook going to get finished?
Yeah, it's finished. Okay, and all the chapters are finished. We finished all the final review. Everything is on. It's fine. And I know that it's going to be sent to printer in July, and in August it's going to be ready to send the physical book. But it's finished and it's reviewed and everything. It's almost done. It's done. Maybe it's minor things, but everything is done.
Okay. And then John that wants to know about SOPs, S-O-P-S, SOPs, which normally for me means standard operating procedure. Maybe you know what it means within the context of security.
SOPs? No, I didn't know exactly.
Yeah, I don't know if it's a security specific acronym or initials, SOPs, S-O-P-S, or is it standard operating procedure, which is, I think, what we talked about already. No. John, let us know in the chat. We got a couple more moments left, though. So there's another question related to, if everything is code, where do you recommend we store the secrets outside of Kubernetes or Vault? Like, would you store your secrets in Git? And, of course, DJ Maddie responds is, well, Git only if they're encrypted, obviously.
Yeah.
So if we don't put them in Kubernetes itself or in Vault, right, HashiCorp Vault, where else might they go?
Yeah, for storing the secrets, as I said, it's like using Ansible or Helm, just encrypt and decrypt and put it on Git, and then you just need to have some kind of process to put the secrets inside Vault or creating the kubectl apply of the secrets to store the secrets inside the etcd. But yeah, outside, let's say that outside Kubernetes, you need to store them encrypted. Of course, as I said, it's not always necessary to do it in that way, because when we think about secrets, it's about database passwords or JMS passwords and so on. But notice that with Vault, these passwords are rotating automatically. They are generated automatically. It means that you don't need to store it anywhere because they are dynamically generated. So it means that you only need to store the username, right? And then Vault automatically will update the password in the database. And if you're using Vault Injector, you will be able also to get this change automatically inside your pod. So this is, or for example, if you're using Quarkus, then Quarkus has a Vault extension which automatically detects these changes and changes the password used to connect to the database. So it means that we can, or the culture of secrets is to try to not have the secrets anywhere. So it's having as dynamically as possible, and this is right. Thanks of Vault.
Rotating keys. Yeah. Okay. Well, fantastic, Alex. Thank you so much for that. And there was a nice comment here, but people really enjoyed the content. I also enjoyed the presentation because there's lots of interesting stuff that you've been researching in this area that is absolutely awesome. I did find the SOPS, right? The short for secret operations. John mentioned it was Mozilla. I also found it on Mozilla. So it's a Mozilla thing. And then I added the chat for you so you can look at it later, Alex. But thank you so much for your time. Okay. I thank you all for being here for our live stream. We're about to switch gears again, so we're going to get out of this stream, and then we're going to set up for the next session talking more about security with Laurent. So that'll be coming up soon. We're going to go do some testing, and we'll be right back on this same channel, not the same URL, different URL, but we'll be back in just a few moments. Thank you all for your time. Bye now. Thank you, Alex.
Thank you. Bye.